this thing? It was like a live mock-up.
This first one, you could do our factoring synthetic if you want, it would work. But I did set this up to be a little easier and factor by grouping. But if you did all the factors of 12, divided by all the factors of 2, and did synthetic and found them how we have been, it'll still work. Or graph it and see where it crosses. Does that make sense, everybody? But I'm gonna do it by grouping because it does work that way. It's a little easier. We take out x squared. And we're gonna be left with 2x plus 3. Here we can take out -4. And we're gonna be left with 2x plus 3 also. So we're gonna rewrite this as x squared minus 4 and 2x plus 3. Remember, equal, equal. We do have something special here, difference of perfect squares, so it does factor. X minus 2 and x plus 2, and then we still have 2x plus 3. It's not asking for the roots, it's just asking for you to factor. So we don't have to set those equal to 0, we're done. Some of you really messed this up on the previous quiz right here. You put x minus 4 and x plus 4, okay? You pull that back out, it doesn't get you that. So make sure, when you get the difference of perfect squares, that is the perfect square part there. Questions on 1? Everybody okay there? All right. Number 2 is where you're gonna need your graphing device. You're gonna graph it, see what's going on. Eliminate some of the factors of 96. Also, it could be a bounce off the x-axis, which means it have a multiplicity, et cetera, okay? So those are all possibilities. So step 1 will be to graph it and see where it's going. Hopefully some of you have done that. Does anybody have a value that we want to try for that first one? 4, okay? So 4 possibly works. I want to check and make sure I need any zeros in there, do I? No, we're good. So we have 1, -2, -32, and 96. Drop down 1, that 1 times 4 is 4. That gives me +2. That gives me 8 there, which would give me -24, which would give me -96 here, which gives me 0. So there's number 1. We had a degree of 3. So now we're down to our quadratic, which would be x squared plus 2x minus 24 equals 0. So we have x squared plus 2x minus 24 equals 0. It is a candidate for the quadratic formula or completing the square since the middle term's even, but this does factor, okay? So I will factor this. We're gonna have x and x. We have a minus, so one's gonna be minus and one's gonna be plus. So factors of 24, they need to have a difference of 2. Are there any factors of 24 with a difference of 2? 6 and 4. Our 6 needs to be here, our 4 needs to be here. So we're gonna finish this up by solving. So here x is 4, and here x is -6. So it does state the multiplicity, which we do have here. X equals 4. It has a multiplicity of 2, okay? And your other root is x equals -6. So there are your 3 roots from that polynomial of degree 3.
Can't you tell if it's a multiplicity of 2 by how it looks on the graph?
Yes,
Okay.
because it
That's
bounces off. It bounces off at 2. Should bounce off either up or down, whichever way it's coming.
And if it goes like that, or whatever,
Then it's a 3
I did -6.
Still work, it'll still work.
But I got x minus 4 and x minus 4.
Yeah, that's exactly what you should get.
Oh, yeah.
Because it's a different triangle, you're left over with different
Yeah,
leftover. It makes sense?
Yeah.
Okay. All right, same thing. How many roots we gotta find here?
4.
Okay. Same deal. Graph it, all the factors of 6 if you need to, by all the factors of 2. Anybody got a number for me that works?
-2.
-2, let's take a shot at it. 2, -1, -14, -5, -6. We do not need any zeros. Don't forget to check and see if we need zeros, okay? 2 coming down, 2 times -2 being -4, which gives me -5. It gives me +10, which gives me -4. It gives me +8. It gives me 3. That gives me -6, which gives me 0. 1 down, 1 more to go there. We got another idea?
3.
3?
Yeah.
Remember, we're gonna use what's left over, so 3. 2 comes down. 2 times 3 is 6, which leaves me with 1. 1 times 3 is 3. Leaves me with -1, be -3. It works. Okay, we're kind of stuck with a quadratic that's not that great, not quick and easy. Okay? So it is 2x squared plus x minus 1 equals 0. I'm going to look and see if I think it might factor. If not, complete the square, it'd be a little bit of a pain. I'd probably use a quadratic. But I'm going to check and see if it factors. Let's see. 2x here, x minus. So we're going to have a minus and a plus, factors of 1. I'm thinking +1 here and -1 here. I'm going to FOIL that to make sure I factored it correctly. Let's see, 2x times that's going to give me 2x squared. That's going to give me plus 2x. It's going to give me minus 1x, and that's going to give me minus 1. So I'm going to have 2x squared, a minus x, oh no, plus x, minus 1. Did I factor it right? Yeah. If you don't see that factoring, then you're going to have to use a quadratic. Everybody got that? So, refresh your memory on a quadratic, -b, plus or minus the square root, b squared, minus 4ac over 2a. You can also complete the square, but I think that might be a little bit difficult with that one. All right, so we did FOIL it to make sure, but we still have to get those roots, which we haven't done. So set these equal to 0. So that x will be -1. Setting this equal to 0. We'll add 1, divide by 2, that x is a half. So we do have 4 of our roots out of our degree 4. Root 1, root 2. The last 2 are gotten by the quadratic, which we factored. 3 and 4. Feel okay about that? Questions anyway? Zucchini, you in zucchini land or are you watching?
I don't know.
I
I do all this stuff right now. He's got stuff like this, like, oh, we can't see your phone.
How did you get the 1/2?
How to get the 1/2? I have 2x minus 1 equals 0. I added 1, so then I'd have 2x equals 1, then I divided by 2.
Okay.
And that's, I just solved there. Does that help?
Yeah.
Thanks for asking. Anybody else? All right, I made number 4 a little easier than yesterday's problems. So let's roll with number 4 now. We have x equals 1. We have x equals the square root of 2. And we have x equals negative square root of 2. Remember, if we have one irrational, we have another. We have x equals I. And we have x equals negative I. If we have one imaginary, we have another. They come in pairs. So on the quiz tomorrow, if I give you this, make sure you know they come in pairs. Everybody got that? Take this to the other side, x minus 1. Take this to the other side, x minus the square root of 2, and x plus the square root of 2. We're going to have x minus I and x plus I. Yesterday we talked about making sure you do the complex FOILing and the irrational FOILing first. Let's do that. X times x will be x squared. That's going to give me positive x squared. That's going to give me negative x squared. So those are going to eliminate. So I'm going to end up with negative times positive, so it's gonna be negative square root of 4, which is negative 2. So those are done. The middle term is eliminated. Remember, these terms will eliminate. This one, x times x, give me x squared. I'm gonna get plus xi minus xi, so I'm gonna end up with negative I squared, which simply becomes positive 1. I still have this x minus 1 down here. I'll stop there. Does anybody have a question? I know I didn't write everything out because the term is eliminated in the middle. Is everybody okay? Questions at all? Everybody okay? I just eliminated those middle terms. All right. Now we got some foiling to do. I'm going to go ahead and do this part here, these two first. So here we go. X to the 4th, right? Plus x squared minus 2x squared minus 2. Combining like things. X to the 4th minus x squared minus 2. Because those combine. And I still have x minus 1 to multiply. Continuing on, x times x to the 4th will give me x to the 5th. That's going to give me minus x cubed, and that's going to be minus 2x. Negative 1 times that's going to give me negative x to the 4th. Negative 1 times negative will give me positive x squared, and then negative 1 times negative will be positive 2. Getting closer. Standard form, x to the 5th minus x to the 4th minus x cubed plus x squared minus 2x plus 2. Take your time and make sure you get through that guy. Again, there's worked out answers on Canvas. Anybody looked at it? Okay, worked out answers on Canvas, and I've already posted the video, but I'm making a new one now because that first one didn't work out so good. So my smartboard was slipping on, my smartboard was slipping all around, so got rid of that. Almost done. If you got this so far, you're going to be doing fine. Our last problem is what we've been working on, the complex roots, all the factors of 54. Again, we're eliminating some of those possibilities by the graph. Does everybody feel comfortable graphing on their graphing device? Okay. You will not be able to use your phone calculator tomorrow. So find one. I'll have 2 available, but those go quick. So if you have a friend in another class, see if you can do it, but no phone calculator. All right, anybody got a number for me that might work? 2. Thank you. Again, check and make sure we need any zeros, which we don't. 1, negative 5, 15, negative 45, and 54. 1 comes down, that gives me 2, that gives me negative 3, that gives me negative 6, that gives me 9. That gives me 18, that gives me negative 27, which gives me negative 54, which gives me 0. So we chose a good one. Of course, I need another one. Any help there? 3?
Yeah.
Okay. 1 comes down, that gives me 3, which gives me 0, that gives me 0. That gives me 9, that gives me 27, which gives me 0. Bingo. All right, we had a degree of 4, we took out an x, so now we're down to a degree of 2. And that's really nice because what's missing from this quadratic? The middle term, and that makes you smile. Without the middle term should make you just say yes, because I don't have to use the quadratic, I don't have the factor, I don't have to include the square because the baby's pretty set up, I'm missing that middle term. Take the 9 to the other side, it becomes negative 9. And now we're square rooting, and we are plus or minus 3i. I do want to show you one more thing. I know that you're fine, but wanna go back up to the previous problem and talk about one thing. Everybody okay with this guy? There's our 4 roots. Root 1, root 2, root 3, and 4. Everybody good?
So when you actually write it down, it's x plus 3i and x minus 3i, right?
Yes.
Okay, yeah.
Plus and minus 3i, yeah. Now, yesterday I made this problem a lot harder, okay? So yesterday, we did this, okay? 1 minus the square root of 2, right? And remember, it's gonna be 1 plus the square root of 2 also. All I had was just that. Yesterday I had 3 plus I, and we also needed what? 3 minus I. We were setting those equal to 0. And then you followed those and got 9 different things, you remember? And the i's went out and the square roots went out, so make sure you realize that that was much easier than tomorrow's gonna be. How we do it? With that being said, I would like to do just one more if you have the patience and if you have a piece of paper available, okay? So let's say we're just gonna do x equals 3 plus 2i. So you know the other one's gonna be x equals 3 minus 2i. I'm just asking you to practice getting the binomial or the trinomial that has those as its roots. Bringing that over, it's gonna be minus 3 plus 2i and x minus 3 minus 2i. I'm gonna give you about a minute to see if you can boil those up. Remember most of those i's are gonna do what? Eliminate. The only I we're gonna be left with is I squared. And that comes out. I posted it last year, I just reposted it, I thought that it was pretty close, but I just wanted to make sure it was the same. There's my 9 terms. Now, of course, some of that stuff's gonna cancel, so I'm gonna look at the i's first. So I have negative 2xi, positive 2xi. Okay. Those are gone. I have a plus 6i, minus 6i. Okay. The one I that I can take care of is this one. This becomes what?
What's -1?
Positive 4.
Positive 4.
But is I squared is -1, Logan, you're right, -1 times -4 would give me that positive 4. You're right. All right, combining stuff now, we got x squared, right? We got negative and negative gives me negative 6x. Those are good. Plus 9 plus 4 gives me plus 13. There's your quadratic with those as its 2 complex roots.
Negative I squared is positive 1.
What's that?
Negative I squared is positive 1.
Yes.
Yeah, negative I.
Negative I squared would be positive 1, because that would be like, negative I squared would be like -1 and then I squared, so it'd be like -1 times -1.
Okay.
Everybody good?